Hi, everyone. My name is Joshua Buck. I'm here with LaShanta from Seed Studio. Today, we'll be presenting a workshop on how to train and deploy your own AI model into a vision AI sensor. Thank you all for joining. And LaShanta, thank you for your presentation today. Let's see how it goes.
Hi, hey Josh, thanks. So I'm Lakshanta and hello everyone for this workshop. This workshop will be mainly about training and deploying your own AI model into a vision AI sensor. So first of all, I will give a brief introduction about myself. So I'm Lakshanta and I'm an application engineer at Seed Studio. So my main areas of focus are IoT, embedded systems, and AI. So if you want to connect with me, you can check my LinkedIn, Twitter, and also check my works on GitHub. So before we move forward, I will give a brief introduction about Seed Studio. So Seed Studio is an open source hardware manufacturer focusing on open hardware ranging from different sensors, sensor modules to single board computers to industrial AI and IoT enabled devices. So we have started in 2008 and produced more than 2095 modules so far. And we have more than 200 regional distributors. Also, we have strategic partnerships with many software solution companies so that we bring software solutions together with the hardware that we manufacture. So we also have agile manufacturing services where you can go from a prototype to a mass production in a very little time. So these are some of the sensors and the modules that we manufacture. So for the sensors, we manufacture different sensors for sensing environmental conditions such as temperature, humidity, soil moisture, water level, and gas. So, and also for communication, we have Wi-Fi, Bluetooth, cellular modules, LoRa modules. We also have main boards based on the x86 architecture, ARM architecture, such as the NVIDIA Jetson devices, the single board computers. So for all these main boards, we also manufacture enclosures, which are suitable to be deployed in industrial scenarios. So if you want to learn more about Seed, you can visit seed.cc, or else if you want to explore all the hardware, explore a range of hardware that we manufacture, you can visit seedstudio.com to enter our Seed Bazaar website. So let's start the discussion like this. So because now this our workshop will be about deploying the AI model into a vision AI sensor. So when we talk about AI, so how has the hardware evolved during the years? So normally we know that the NVIDIA RTX platform is the latest GPU platform released by NVIDIA, and this is the platform that many people are familiar with when it comes to AI training and deployment. But now NVIDIA has their other embedded system based platform, which is the NVIDIA Jetson platform, which is much smaller than this RTX GPU platform. Because if you want to have this kind of GPU, you want to build an entire system, entire PC, which is very big, and it's hard to deploy in at the edge scenarios. So for edge scenarios, this kind of small form factor is now there by NVIDIA. So next, there's the MCU platform. So now we can even perform AI on the microcontroller units. So it was never possible before. So because we didn't have the enough like AI processing capabilities on the MCUs to do this. So now we have the MCU such as the Vio terminal. And for this workshop, so we are mainly talking about the Grow Vision AI module, right? So this is that module. And this module is very small compared to all this. So this is also able to process and inference the AI models on the device itself. So as we move down, right, in size, so from the biggest one to the smallest one, what there is a bit of a sacrifice here, because the big AI models that can be run on this NVIDIA GPU platform cannot be run on this one, because it does not have the exact same hardware capabilities. But with the advancement of software engineering, we have now optimized models which are able to run on small microcontroller hardware like this. So so that is what enables, I mean, those optimized models enable these small microcontroller unit based devices to perform AI. And also another important thing is, because of this small size, we don't want to spend a lot of power for these devices, because to power these big devices, we need a lot of power actually to use these devices. But for this small devices, they need very little power. So I will briefly explain. I will briefly introduce the Grove Vision AI module that we are going to talk about in this workshop today. So as you can see, this module is very small. So it's like it's 40 millimeter by 20 millimeter. So if I show you, so this is the particular module. So it's very small, as you can see. Yeah. So it's powered by a HiMax chip with 400 megahertz DSP, and it has a onboard camera over here, which is based on the OV2640 chip with a resolution of 1600 by 1200. So this particular module supports object detection and image classification. And also, so not only it has a camera, but also it has an onboard microphone and a 6-axis accelerometer. So which means you can build even more applications, not only the vision AI applications. You can also build AI applications using the mic and the accelerometer. So there's another thing, that is this inbuilt Grove connector. So by using this Grove connector, you can connect this Grove Vision AI module into a microcontroller, such as the YO terminal, so which I'm going to show you very soon in this workshop. So if you want to learn more about this module, you can visit this wiki page, which has all the instructions about getting started with this module. And if you want to, so you can also scan this QR code to access the web page easily. So this is so I will give a brief overview of the hardware of this module. So as I have mentioned before, it has a HiMax chip. So this is a particular HiMax, the version of the model of the chip, HX6537A. So it has a camera connector, DC-DC chip, the Grove connector I mentioned. It has a power indicator light and a burning indicator light, because this burning indicator light will be helpful when we are flashing the models into this module. So it has a BL702 chip, which is the USB to UART chip, and there's a mic, 6-axis accelerometer, there's a SPI flash, USB Type-C connector, and it has a dual 7-pin female socket. So this is the so it has 2 rows of female headers, and a reset button, a boot button, and a user button. So when you buy this module, the Grove Vision AI module, what can we do with it? What ML algorithms can it run? So when you so out of the box, when you open, you buy the device and you open the device. So what you get inside is a model which is trained on Ultralytics YOLO v5. So now we have partnered with Edge Impulse to bring their latest FOMO object detection algorithm to the Grow Vision AI. So that is what we have been working on with Edge Impulse together. So because we believe that the FOMO can really help to run the AI models and have a better inference performance, better frames per second than the YOLO v5, because YOLO v5 is mainly optimized to run on hardware which has more hardware capabilities than a small microcontroller like this. And the FOMO is mainly optimized for small microcontrollers like this. So that is why we wanted to do this. And now we have successfully integrated the entire FOMO object detection algorithm and the entire Edge Impulse workflow into our device. And we will be walking through each and every step of deploying this particular algorithm, and finally performing the object detection on this device. So when you so this particular module, so you can buy it separately, right? But it also comes inside this kit. So we have this particular kit, SenseCap K1100 kit, which is the sensor prototype kit. Has different modules, like it has a soil moisture sensor module, LoRa module, temperature humidity module, right? So and it also has the wire terminal that I mentioned before. So wire terminal is acting as the main microcontroller. It's the brains of this kit. And the Grow Vision AI module, which is over here, is also a part of this kit. So you can either buy this module separate, or buy this kit, which comes with where the Grow Vision AI module comes inside this kit. And when you buy this kit, so after you buy this kit, if you want to get started with this kit, you can visit this wiki page, and or else you can scan this QR code to access it. So now let's get hands on how it's going to go, how it's going to show all the detections on the Grow Vision AI module. So this is the out of the box experience, as I mentioned before. So it comes with the YOLO v5 model out of the box, and it's flashed with a model that has trained on a people face detection data set. So let's quickly go through what is installed inside this wire terminal. So this is the firmware that is installed inside the wire terminal. This wire terminal, when you buy the SenseCap K1100 kit. So if you visit this GitHub page, right? So I will quickly go there. SenseCraft. Yeah. So this is the firmware which comes with the wire terminal when you buy the SenseCap K1100 kit, and you can visit. You can read all about the features of the firmware, what you can do with it, and after you access the GitHub page, you want to go to releases, and then grab the latest release from here, and then flash the UF2. There are UF2s over here. So because we wanted to make the flashing process much convenient for the user. So what we did, we have this workflow where you just want to download the .uf2 file from this GitHub repo, and then connect the wire terminal to the PC and enter the bootloader mode on the wire terminal like this. You can follow this GitHub. And after that, on the PC, it will show a USB mass storage drive. And what you want to do is you want to simply drag and drop the .uf2 file into the USB mass storage drive, and then the firmware will be flashed to the device, to the YO terminal device. So this is the exact same procedure that we will do with the Grove Vision AI as well later in this workshop. And for that, I will go through step by step on how to deploy it. But for this scenario, for this deploying of the YO terminal, I will just go through this GitHub for now. So after that is loaded, yeah, so then you want to connect the Grove Vision AI module into this the right side Grove connector. So once you do that, so I will now quickly show you how it looks like on the YO terminal. So I have the YO terminal here, and we'll power it. So this is the YO terminal device, and yeah, so we'll power the device. Yeah, so now the SenseCraft firmware is loaded to the device. So what we will do is you have the Grove Vision AI module, and then we connect a Grove cable to the Grove connector on the Vision AI module, and then we have two Grove connectors on the YO terminal. So we want to connect this Grove Vision AI module to the right side Grove connector, right? So we connect to the right Grove connector. So you see, as you can see, it's very easy to connect all these sensors to the YO terminal using the Grove cable because of the Grove connectors on the board. So after we connect it, okay. So I will connect another because now we want to see the results on a web page. So to see the results, the object detection results on the web page, we want to connect this Type-C connector into the PC. Let's connect it to the PC. Yeah. And after that, sorry. Yeah, after that, you need to go to yeah. Okay. Let's connect it. Yeah. So you want to go to this this URL, files.steedstudio.com/Grove AI Vision/index.html. So you need to access this. You need to enter this URL and then enter it and then connect. After that, connect this. Yeah, and then select Grove AI tab and connect. Yeah, okay. Because yeah, before the application is different, it's for a different application, because right now the people detection model is loaded into the device from factory, and it will show it will switch to this view where you can see. Okay, I will point at my face. Okay. Yeah. So almost there. Yeah. So as you can see, it's detecting my face. So yeah. So that number, yeah, 85. So that's the confidence, right? 85% confident that it's a face. And 0 means it's just like a tag which says it's a face. So if there are two faces, it will have another, it will also have 0 and the confidence next to the 0. Yeah. So this is the out of the box experience with the Grow Vision AI module together with the YO terminal. Yeah. So that is about that. And now let's move to the edge impulse workflow. Yeah. Yeah. So now let's see how this all looks like with edge impulse. So this is the basic workflow for edge impulse with the Grow Vision AI module. Okay, so give me 1 minute. I will get this out of the way. Okay. So first of all, what we want to do with edge impulse. So we first need to collect the data, right? So collect the data set. So to collect data, we first need to connect the Grow Vision AI module to a PC and then update the firmware on the Grow Vision AI module. Because otherwise, because first of all, the Edge Impulse Studio needs to connect with the Grow Vision AI. So to connect with the studio, you need to have that particular firmware. So we update the firmware to the Vision AI module, and then we collect the data from the Edge Impulse Studio. And after that, we annotate the data. And after annotating means drawing bounding boxes for the objects that you want it to detect. And then after annotating, we train the model on the studio. And after training, we generate a model, and we flash that model into the Grow Vision AI module. And then after that, we perform the AI inferencing, which will be weaved on a web browser. So all this, so I will walk through all this next. So so let's go into this URL. So because now the Grow Vision AI module is listed as an officially Edge Impulse supported board. So this support just released a few weeks ago, and let's go to this URL. So docs.edgeimpulse.com. So once you go here, you can see Edge Impulse supported MCU targets, and in there you will see the Seed Grow Vision AI module. So this is the getting started documentation for Seed Grow Vision AI with Edge Impulse. So as you can see, first of all, you need to install the dependencies. You need to install Edge Impulse CLI. So that's the requirement from Edge Impulse. And so these are all the instructions for installing Edge Impulse CLI, which supports Windows, Mac OS, and also Linux. So after you do that, after you install the Edge Impulse CLI, because I have already installed Edge Impulse CLI on my PC. So after you do that, you want to download the latest this Buffalo Lab Dev Cube. So that is because we want to update the BL702 chip firmware on the Grow Vision AI module, because earlier when we tested this Grow Vision AI module with the Edge Impulse, there were some issues with the BL702 firmware. So we have fixed those issues, and now it works well with Edge Impulse Studio. So to make it happen, first you need to update the firmware. But in the future, we will have this BL702 chip firmware already updated out of the box or from factory. So you will not need to do this in the future. But for now, you need to do this. You need to update the BL702 chip firmware. So you can go through this instructions to update the BL702 firmware. So for me, I have already updated the BL702 firmware on my Grow Vision AI. So I will skip it for now. And also, if you are watching this video in a later point of time, where if your Grow Vision AI module is already updated with BL702, you don't need to do this as well. So I would recommend you maybe to skip this part at first if you are following it later, and then go through all the other steps. And if it does not connect with Studio, then you can come back to this section and update the BL702 firmware there. Yeah. So if it doesn't work with Studio, so that will be the most fastest way, right? Because there is no order where you need to update BL702 first and then update the Edge Impulse firmware. You can do it in a different order. So I would suggest you to do update the Edge Impulse firmware first if you are following this video later in a later point of time. So so this is about updating the Edge Impulse firmware. So we want to grab the latest Edge Impulse firmware from here. So let's do that. So click on this, and then it will download this Grove Vision AI.zip file. So let's open it. Okay, so I will yeah. So this is the downloaded file, and then we will extract it. So once we extract it, we will have .uf2 file. So what we want to do is, as I mentioned before, we simply need to get this Grow Vision AI module and connect USB Type-C cable to the Type-C connector like this. And the other side, you just connect to your PC. So, and after that, you simply need to enter the bootloader mode. So to enter the bootloader mode, there's this button over here, the boot button. So you want to press this boot button 2 times. So you need to press it quickly. So 1, 2. Yeah. So once you do that, you can see there's a new drive popped up here named Grove AI. So we can also see the drive over here, just to give you to show you. So this is the drive, Grove AI. And what we want to do is we want to copy this .uf2 firmware file. Copy, and then paste inside this Grove AI drive. So let's paste it. Yeah, so you can see it's very easy to flash the firmware. So we have made it easy for the audience, for the end user. Yeah. So it disappears, right? So if that Grove AI drive disappears, that means the firmware .uf2 file has been successfully flashed to the device. So now, okay, so these are the instructions that I this is what I have told before, about entering the bootloader mode, the mass storage mode. So after that, we want to open Edge Impulse Studio. So that's where we will do everything from here on. So So this is the Edge Impulse Studio. So to visit Edge Impulse Studio, you simply do studio.edgeimpulse.com, and then you need to actually create an account here. So because I have already signed in with my account, but for you, when you open this studio.edgeimpulse.com, it will look something like this. It will look something like this, where if you have an Edge Impulse account already, you can log in, or else you can sign up by clicking this. So I have already signed up. So now I will create a new project. So create a new project, and let's give it a name, face detection. Yeah, and then create it. So I will select this developer. And because it's free to get started with Edge Impulse, so if you select developer, so now the project is created. So after that, what we will do, we will connect the Grow Vision AI module into the studio so that we can collect a data set, collect some images to form a data set. So let's go to the devices. So there's no device connected right now. So let's quickly connect this device. So let's open up a terminal, command prompt, and then type Edge Impulse daemon, DAEMON. Yeah, because I'm able to execute this command because I have installed Edge Impulse CLI as I have showed before. So Edge Impulse daemon, and then let's do a clean, because clean will make sure that it will clean up everything, my history and all the previous stuff. So it asks for the email that I signed in on Edge Impulse. So then it's asking for my password. So I will enter my password there. Okay, my password is this one. Okay. Yeah, so it asks what name do you want to give this device. So Grow Vision AI. Yeah, so now it's connected. So over here, I only have one project on Studio. But if you have multiple projects on Edge Impulse Studio, this daemon will this particular window will ask you which project that you want to connect Grow Vision AI into. It will give you all the projects that are available on your studio. But for me, since I have only one project on Studio, it will not ask about it. It will directly connect to that project that I created a few minutes ago, the face detection project. So if you go back to that and let's refresh, and we can see the device is online on the studio with the name that I just assigned, the Grow Vision AI. So now what we will do, we will generate a data set. So let's go to data acquisition, and then so this is the camera feed, the live camera feed. You can see that this is the live camera feed. Bring my system. So this is the live camera feed. So let's give label. Oh yeah, so I forgot one thing. So let's go back to the dashboard, and we want to select what kind of project that we are building. So the labeling method. So one label per data item. So this is mainly for classification, and this one is for object detection. So we want to select this option, bounding boxes, object detection, right? And then go back to data acquisition. So let's make this face. And for the camera, select 160 by 160, the maximum resolution from here. And the device is selected, the Grow Vision AI device. So, so let's collect some data now. Okay. So what you want to do is you point the camera to your face like this. Yeah. Let's grab some images. So first, let's grab some images under train, and then so train, let's have 15, and for test, let's have 5. Okay, so let's do it. Josh, the workshop is still rolling, right?
Yes, it is. You're doing great, Lashanta.
Okay. Just want to make sure that I'm not disconnected. Okay. Maybe a different angle. Yeah, actually, what you want to center your face like this. This is not that good. Like, because later on we want to draw the bounding boxes over the face. So far we have yeah. Okay, let's continue. So we have around yeah, Josh, it's supposed to show the number of images over here, right? Okay.
It's showing the labels.
Oh,
You need to
this
make
one,
sure.
right?
Yeah,
Yeah,
and your
this
labeling
number,
queue.
right? For sure. Yeah. I thought the number is going to show over here. Okay.
No, you
So,
have unlabeled data, and so
right.
when you collected it, you can go into the labeling queue there,
Yeah.
and then go fix unlabeled data before you
Right.
do your training.
Got it. So let's grab 3 more.
And really, what's going on here is, since you're going to be doing an object detection model, you'll want to go in and draw bounding boxes.
Yeah. Okay, let's get 5 more for test. Yeah. Okay. Okay, 4 more. 4 more images for 4 more. So actually, what we are doing is, so we are only having 20 images here for this, but like if you want to build a entire like a proper object detection, oh yeah, a proper object detection model, then you want to have at least like 100, like 150 or 200 images, right? So just for like this workshop purpose, I'm only collecting 20 images. But in this situation, it will be okay because we are using the same lighting and the same location to do the detection. So it will be okay for this. But if you want to detect for different lighting, you want to have different data sets. No, different you want to grab data with under different lighting conditions and different locations and different people as well for a face detection project. Okay, we have one more. That should be good. Okay. So after that, yeah. So let's move some data to test because normally you would click on this test data and then grab uh, the frames from here. But since I grabbed all the images under train, so we'll select maybe 5 from here. 1, 2, 3, 4, 5, and then click this move to test data. So now it's moved to test data. You can see here. And let's go to labeling queue, and then let's start drawing bounding boxes. So you need to select this track object between frames for this particular application, because we are only trying to detect the face. And as we switch through the images, it will try to predict the bounding boxes for us if we select this. Or else if you have multiple objects, then you might want to select this classify using YOLO v5, so that it can try to detect different objects inside the image. So let's do track objects, and then label the image face. Yeah. As you can see, it tracks. So we just want to adjust a little bit and make sure the labeling is tight. So if you're labeling a face, make it as tight as possible so that the detection accuracy will be better. Yeah, so yeah, this is good. So tiny change. Yeah, that's good. It's good. Yeah.
So you can also use public data sets. You can bring in public data sets to train on Edge Impulse Studio. But if you want specific like applications, want to build specific applications for your custom use scenarios, so you want to have your own data set. So that's why we want to do this labeling, drawing bounding boxes. Yeah, so now we are done with it. So after that, we want to go to impulse design, and in there first select the input image size. So here I will select 160 by 160, and then for the post processing block, image, and for the learning block, select object detection, and then select this save impulse. After that, go to image, and then make sure this is selected as grayscale, because through our testing, we found that if we select grayscale, we can have a better inference performance. So we select grayscale from here, and then click save parameters. Then we generate features. So let's wait a little. Let's wait a little for this. It'll take a couple of seconds to finish. Maybe Josh can explain what's going on here. Oh, okay, it's done.
Yeah, so when we are generating features, right, what we're trying to do is decide what's important of the data set to feed into the model, right? So when you take a raw image, it might be of a certain size, a certain height and width, okay? And the data channels might be RGB or color. When you're generating the features, instead, you're deciding, okay, maybe I can reduce, instead of taking the whole image, I can reduce it down to a certain size. So in this case, if we look back at the impulse design, I forget, did you choose 96 by 96 or a different image size? But in other words, you're not going to take the full, all the pixels of the image. You're going to shrink it down before you feed it into the model. And then, of course, you change the color parameters. In non-image based applications, you'll have the ability to change, to generate features based on like power spectra, FFTs, MFEEs, MFCs for the audio models as well. So feature generation is a very important pre-processing step that you do before you actually input the data into a model.
Thanks, Josh. So yeah. So here what you do is you now we start training the model, right? So we will keep these numbers as default. Just click on start training. So as you can see, the FOMO update detection algorithm is already selected by default. So just keep that. Yeah, and this is also selected. It will do some augmentation, data augmentation. So which means, Josh, it will like try to maybe stretch some images, change the color settings and stuff like that, right? And make the data set a little bit more, multiply.
Correct. If you go back and highlight over the question mark there about data augmentation, this is very important to help expand a training set that you have. So here you may have only collected a few images, but exactly like you said, right? We're trying to stretch things, change things, skew the data a little bit so that you essentially get more training data artificially without having to produce more images or more training data sets.
Right. Yeah. So this training is going pretty fast because we don't have a big data set. So yeah. Yeah, it's almost done, I think. Profiling. Yeah. So this is what we get. Yeah, so that's a pretty good F1 score, but yeah, I mean, it can be better if you have a big data set. Yeah. So here we only have 20 images, right? So, yeah. So next, what we will do is we will go to deployment. And then over here, you can see the Grove Vision AI module, right? So this block. So you simply need to click on it, the Grove Vision AI block, and then you can either analyze for optimizations here, but we will just directly go to building the model. Because like right now it's selected as INT8, which will give you the best performance compared with float 32.
So what this mainly does is this packs the Edge Impulse firmware and the model together into a UF2 file, so that we can simply flash into the Grow Vision AI module as we did before. So it download as a zip file, and then let's extract it. Extract. Yeah, so this is what we get, the firmware.uf2. Yeah, so let's open up the terminal. Oh yeah, we forgot to, yeah. So before we we executed the Edge Impulse daemon command. So just quit that. So Control C to stop this, and then yeah, enter the bootloader mode as I explained before by pressing this boot button 2 times. 1, 2. Yeah, and then copy this UF2 file, which includes the Edge Impulse firmware and the face detection model that we just trained. Copy and then paste into the this drive, Grow AI drive. Yeah. So once it is done, we want to open the terminal again, and then type Edge Impulse run dash impulse run impulse, 2 dashes, and then debug. Yeah, so you can visit this URL. Press Control on the keyboard and click on this. Oh. It's not selected. Yeah, okay. It should open a web page. So this is the, so now let's see how it's going to perform. So as you can see, it's detecting my face, right? Yeah. Saying face with the confidence score, 56, 60. Yeah. So it's not that accurate because, yeah, it's as I mentioned before, it's only trained for 20 images. But even for 20, it's doing a pretty decent job at detecting. Yeah. Okay. So as you can see, the time for inference is pretty high over here, 237 milliseconds, which translates into around 5 FPS. And that is because we set the input image size to 160 by 160, right? But if you select the image size, right, in the training section, if you select the image size as 64 by 64, the inference time would reduce to 47 milliseconds, which will translate to 21 frames per second. Right? So, which is like, it is very good, which is like impressive for a microcontroller of this size. So, and 64 by 64 is also doing a pretty decent job at detecting the faces. So yeah. So next, yeah. So not only you can bring you can train your model on the Edge Impulse Studio, or like import public data sets. You can also go to Edge Impulse ready to go public projects.
So if you go to this URL, so here you can see, okay, so if you type face,
so there are some projects made by Agimpulse and some projects made by the community as well.
so this is by Agimpulse. So this is a face detection
Project.
So actually this can be directly deployed to the device. I mean,
You just simply need to clone this project by clicking this button, and it will go into your it will go under your account as a project,
and then you can deploy. Simply click on deploy button, select the Grove
AI vision block, build the model, and then deploy the generated .uf2
into the device. So, and also
the advantage of having
this
this ready to go projects is that if you want to improve the accuracy, maybe once you deploy this model, it's not performing that well for you.
What you can do is you can go ahead
and add more data into this data set.
So here you have 314 images.
So you can import, you can add your own images, just as I showed you before. After connecting the Grove AI Vision module to the Agimpulse Studio, you can use that to grab images and then add into this existing 314 images data set to make the accuracy even better for this face detection project.
So yeah, and then yeah, so after that, yeah, so those are the public projects. And then, so if you're a developer, right, if you are a developer, you can visit this URL. So this is actually the source code for the Agimpulse for the
Grove Vision AI Agimpulse
firmware. So if you visit this source code, yeah.
So actually, this source code is updated with the Agimpulse Studio.
So if you want to
integrate this Agimpulse firmware source into your own application,
you can use this. And so what you want to do is you want to go to your face detection project, deployment, and then after doing the training and everything on the studio, on the deployment section, click on C++ library, and then build. Click on build. So after you do that, it will generate 3 files. So you need to copy and paste these 3 files into this particular section. If you want to, yeah, over here, this directory. Yeah.
So it's mentioned here.
So simply
copy and paste those 3 files generated after selecting C++ block inside the deployment section.
You copy and paste those 3 files into this, and then you make the you compile the
firmware from here, and then you can implement this to your own custom application. Because normally what we showed before, the web preview, right, the where my face was being detected on the web page. So this is not what a developer would want if you want to integrate into their own solution, because they only want to grab maybe the detection results only. Like they want to just grab, okay, so the face is detected, right, with a confidence score of like this much. So they only need that particular information to integrate into their application. So in this kind of scenario,
So this is the way to go by using by compiling from the source of the Grow Vision AI Edge Impulse firmware. Yeah. And then, so we also have the Edge Impulse community boards. So if you visit this, because Seed also has some boards listed under the Edge Impulse community boards. So if you go here, community targets, and this is one board, the Seed Wire Terminal. So the wire terminal that I mentioned before in this workshop, so that is also directly supported by Edge Impulse, and you can connect the wire terminal to the studio and yeah, collect data, because it has like accelerometer, microphone, and you can collect data from those sensors on the wire terminal, and you can follow this. Also, we have the Seed Recomputer Jetson, powered by the NVIDIA Jetson platform, which is also like under the community supported boards. So you can follow these documents if you want to. If you also have these devices and want to connect these devices with the studio and build your AI applications. So that is it for this workshop. So I hope you guys were also able to follow along with me and then deploy the face detection project onto your Grow Vision AI module as well, and obtain the same results as me. So if you want to connect with us, you can visit the LinkedIn. We are available on social media platforms such as LinkedIn, Twitter, and also we upload videos on YouTube, and we are very active on Discord. So if you have like questions to ask from us regarding the Seed products, you can ask over at Discord. Also, we are on forum, the Seed forum. And also, if you want to explore a wide range of projects that our community has built using the Seed products, you can visit the Hackster project hub. So thank you all, everyone. Thank you, everyone, again. And I hope you guys build exciting AI projects using the Grow Vision AI module.
Great. Thank you, everyone. And thanks, Shanta. And we'll all hope you have a great day. Thank you.
Thank you. Thank you.